All right, good morning, everyone. What's on your minds today?
I had one question about Examity and then two about the actual work.
Okay.
With Examity, it told me that I needed to work at a clear desk of all other objects. I have a desktop PC on my desk. Do I
hmm
have to unplug my monitors and move them, or is turning them off simply enough?
Turning it off should be fine.
Okay,
Yeah, someone else had that same issue.
okay. Let me just find the problem here.
So the exam starts at 2. We log
Correct.
in, we log in at 1:30 though,
Um,
or something like that.
Around 1:45 would be closer to the time.
Okay. And then you said it was 90 minutes.
Correct.
Okay, with like a 15 to 20 minute upload time at the end.
Yeah. There's a total of 30 extra minutes, but that's to log in, and then part of it's logging in, part of it's taking pictures. So
Okay.
overall 2 hour block to get everything done.
Okay. I've never used what do you call it, CrowdMark on my phone, like to upload photos. So I'm assuming I can do that all like in my web browser or my phone, hopefully.
Yeah, and actually what a lot of people have done is taking a picture with your phone and then sending it as an email to your computer and then uploading from there.
Okay.
Um, I would advise that you have an app on your phone to change your picture into a PDF just to make the uploading a little bit quicker. Although Wyatt, you and I talked about some other ways that you can handle that.
Yep. Yeah, no, I was just gonna when I take photos, they auto upload the Google Photos, so
Okay, yeah, if it's all the way, if it you can then
photos and
get it
download them.
on your, yeah, that would work very nice.
Yep. So
I
I'll do that.
always I always upload them on my phone. It's just you got to rotate each picture, so it's a little annoying. But
Yeah, even when you use
Would
your computer, sometimes it has to do that also.
yeah,
would you be fine if I just uploaded JPEGs and then re-upload the PDFs once I do the proper scan?
Either way.
Okay. Because I don't have an app right now on my phone to do the scan to PDF.
Okay.
So
Anthony, do you have your specific questions found?
yeah. 13.3, question
Okay.
11 on the WebAssign.
quick question: did you guys ever upload answer keys to the CrowdMark homework?
I do not think that they put the answer keys up.
Okay. Is there a way we could see those,
I
or your
well,
notes on your comments on incorrect stuff is
yeah,
uh,
my comments on that are the feedback you're going to get. So those are not my assignments. So I do not have the answer keys. Although actually I have a version of the answer keys, but since they're not mine, it is not my privilege to put them up. It
Yep.
would have to
Okay.
be Dr. LaRue, and she would rather not. Um, However, if you are ever working through something and you want, okay, I see your comment here. Now I reworked it. Did I do it correctly the second time? Feel free to send me an email and
Okay.
go from there.
Okay. Sounds good. I was just curious. That's
hmm
all. Yeah, she
All right,
didn't upload them last semester, so I'm sorry. I'm interrupting him.
that's fine. I was looking up the thing on WebAssign anyway. So it looks like the was it 7t squared t cubed. Let me double check.
The one I'm looking at says find equations of normal and oscillating plane of the curve at the point x equals 7 sine 3t.
11. I thought you said 7.
Yeah.
All right. So x equals 7 sine 3t, y equals t, z equals 7 cosine 3t, and then our point is 0, pi, -7. Okay, so looking at this, the one that has your t in it will probably be your easiest one to deal with. And since it's t and it's going to be pi, we know that our t is going to equal pi. Okay, so at least we have that down. Now we need to find normal and oscillating planes. So we're going to have to find our unit tangent vector, our normal vector, and the binormal vector. So what we can do is make this a vector and then find our derivative. So 21 cosine 3t, 1, and then negative 21 sine 3t. Now we need to evaluate this. Well, we're going to have to find our length of this. So our magnitude of r prime will be the square root of each of those squared. So 21 squared cosine squared plus a 1 squared plus another 21 squared sine squared. So it's basically 21 squared plus 1.
$441 plus 1.
442. So it's square root of 442. So our t vector is going to be 21 cosine 3t, 1, negative 21 sine 3t all over square root of 442.
Is it acceptable to leave it like that, or do we have to break it down into each component of like 21 over root 442, 1 over 442, and then the sine?
If we were asking you to find just the t as a final result, I would want you to split it up and break it into each little bit.
Okay.
Since this is just a step in the process, it's not going to make much difference. All right, next we need to find our t prime. So negative 63 sine 3t, 0, negative 63 cosine of 3t. all over square root of 442. Next, we need to find the magnitude of that. So this is going to be a little bit easier to do. You have a 63 squared or sine of squared plus a 63 squared cosine squared. So it's going to be the square root of 63 squared. So therefore,
63.
And so finding your n, it's going to be your t prime. Whoops, that should be a t prime in there. It's t prime divided by the magnitude of t prime. Your square roots of 442 are going to simplify. So n is just going to be a negative sine 0 negative cosine. So that's just simplifying pretty nicely. Questions up to there? Okay. Next, we're going to need our binormal vector. So let's get a new page. Binormal is your t crossed with your n. So we had our 1 over square root of 442. We can throw that out front. And then it was a negative 20 or positive 21 cosine. And I'm going to simplify this a bit. A 1, negative 21 sine. Then for here was a negative sine 0, negative cosine. Now we do our work. Have that multiplier out front. With our I, it's going to be a negative cosine times then a 0 or plus a 0. For our J, it's going to be a minus 21 cosine squared minus a 21 sine squared. And for our K, it's going to be sine.
Could that Y? Yeah, okay, never mind. It was hidden behind the pictures.
Okay.
I didn't see that you simplified it.
And let me,
Would that simplify to negative 21 or just 21?
it will be a negative. Because whenever we do our, and let me write this a little cleaner. Whenever we do our setup, we have to go backwards first, then we go forwards. So it's even though we go backwards, we're keeping it as it is. So we go from here to there, negative cosine 21 cosine squared minus the 21 sine squared. So they both still have the negatives in there. So we factor the negative out, and then you get your 21 sine squared plus 21 cosine squared. So yeah, this is a long process to find this whole thing. Now what we need is the normal and the osculating plane. So normal plane has the binormal vector and the normal vector. So in order to find the plane that holds those two, we need to cross them. So and let me actually change this. So I, J, K. Here's our normal vector. We'll pull that out front from the binormal, and we'll have a negative cosine minus 21 and a sine. So we would end up with a cosine squared for the I. It would be a minus sine squared minus a cosine squared, just one for the J. And for K, it's going to be, actually, sorry, that should be 21 in there. 21 sine squared of 3t. Questions up till now?
That's the equation of the normal plane?
Well, that is the normal vector for our normal plane, or the
Okay.
vector that's normal to it. Now, we wanted this specifically where t equaled pi. So if we went back to our beginning, we found out that our t doesn't equal pi specifically. So that's what we're going to do. Let's make our t equal to pi. So for our first one, plugging a pi in is just going to be 21. That's going to be just 1. Plugging a pi in is going to be 0. So there's the vector we're going to use. We need to now find a point. So we need to find a point whenever somewhere on our vector, either your normal one or your binormal one. So a point that we would get is 0, 0, 1. Actually, yeah, 0, 0, 1. Just plugging stuff into our n vector down here. make your t a pi. Although that's going to be the direction we're going in. Oh, we have a point. So we don't have to worry about finding a point. Although, yeah. So let me get a new page. And let's consolidate. So our point is 0, pi, -7. And our vector is 21, 1, 0. Times 1 over square root of 442. So in order to come up with the plane for this, it is our x times x minus the x value plus our y times our y value plus z minus the z value equals 0. And actually we can get rid of the square roots of 442. And we can simplify it down to there.
How'd you get rid of? Oh, because it equals pi over root 442.
Mm-hmm.
Gotcha.
The answer says it should be a negative 21x. Where did I mess up? I missed a sign somewhere. Oh, it's back here. Since we got our thing coming this way, it should be a negative of that. So that's negative. That's negative. That's negative. That's negative. That's negative. That's negative. Okay.
And so that's the equation of the normal?
That is the normal plane. Yes. Now the osculating plane should be pretty easy to do because it's going to hold your unit tangent vector and the normal unit vector. But in order to get your normal vector to that plane, you're going to cross them. But we already crossed them. So whenever we have our crossing already, let's plug in a pi to that one. And so we would get 1, -21, 0.
So the oscillating plane is just the binormal vector?
So actually, we could have just, instead of crossing our n and b, we could have just used our t vector. Because the way we have things set up, t is there, n is there, b is there. So if you take any one of these planes and cross them, if you take your bn plane and cross the two vectors, you're going to get something that lies along your t, or that lies along negative t, depending on the order you did it in. If you take your t and your n and you cross them, it's going to be your b or your negative b. If you take b and t and cross them, it's either n or, going the other way, negative n. So yeah, we could have just completely skipped this step and just used our t vector and just plugged numbers in, plugged your pi in, which is essentially what we got. It would have been a little bit easier too. So for our normal vector for this one, our point is still going to be, what was our last one? 0, pi, -7. And our vector, going back to what we had for our b, square root of the 1 over the square root of 442, then a 1 and a -21. So writing it out, 1 x minus 0 plus -21 y minus pi, and again plus a 0, z plus 7 equals 0, and then this will be over the square root of 442. This is over square root of 442. But again, we'll be able to multiply by that square root of 442 and they'll disappear. So it's x minus y, or 21y, equals -21 pi. And again, they say I'm missing a negative somewhere. Or is that 21? Should that have been positive? Yep, I made the mistake again. That should have been a plus. So, whoops, not that there. That should be a negative. That should be a negative. That should be a negative. So therefore we can make all of these positives. So, Anthony, do you want me to go back through any of these slides so you can see them again?
Yeah, just a quick rifle through to make sure I
Okay.
wrote everything down.
So here's the beginning one, and even if you want to do a screenshot of each of these.
Okay, got that one.
Okay, that one's good.
Yep, I got that one. Yep. Yep, I got them all.
Okay. Now I still think I messed up somewhere along here because now this one should be a plus. So I'm not sure how that's going to screw things up.
So if we were to just generalize how to find the normal and oscillating plane, it would be find down to the binormal vector and a point.
Yeah, because your
Okay.
binormal vector is going to be the normal vector of the plane for your oscillating, and you know the point they gave, and they gave you the point from the beginning. For your normal plane, it's going to be using your unit tangent vector and going from there.
So binormal vector and a point. And then for the normal, it's the tangent and the beginning point.
Say again, for the normal plane, it's the unit tangent vector and your beginning point, yes. So it's always going to use that beginning point.
Okay. I'm just trying to find ways that I could remember it better.
Mm-hmm. So the clearest thing for me is to remember you're drawing from the beginning.
Okay.
So, and actually I'll get a new page. And so if you're going to draw some curve, your tangent is going to be there. Your normal's there. And your B is going to be coming out of that. Well, actually, it's not coming out of it.
It's at a 90 with both the tangent
It's going,
and the
yeah,
normal.
it's going actually
Okay.
into the plane the way, or wait, right hand, yeah, it's going in. But that's a right hand, that's right. So you still get like an axis.
Okay.
So there's your setup in relation to a curve. So the binormal plane is pretty much going to cut across into a cross section of your graph. And it's going to get these two. Your
Okay.
oscillating is basically going to take your tangent and your normal. So it's kind of going to be taking a sheet of paper and basically putting it into the plane that you're drawing this in. And so it's going to be the flat section there. But remember that the normal plane has normal vector and binormal vector. So it has everything with a normal in it.
Okay.
Osculate, that is, I think it's either French or Latin. It's some other language, but it means to kiss. And so you're kissing right up against your curve. So it's going to come, whatever your curve is doing, it's going to kiss right up to it.
Okay.
And that's the way I remember where the positioning is. And then once you get the positioning, it's easy to know, all right, which two vectors are going to be included Okay, so then how do you find a plane from two vectors? You cross them, use a point, do your equation.
Awesome. I remember from last semester there was a question about why the binormal is also a unit vector.
Mm-hmm.
Can you run through that explanation for me?
Yeah, and actually I want to go back just so we have this on record for the video. I believe this number is let's see, where are we at? This number was or this value was incorrect for our setup. However, it's not going to make any real difference doing your J stuff. Because our signs will disappear. So this should all work out, that we get our same numbers, even though I messed up on this a little bit. So doing the thing about your vector. So your unit tangent vector, it's a unit vector. Your normal vector is also a unit vector. Your binormal is tangent crossed with normal. So we want to figure out, how do we know that the binormal is a unit vector? So therefore we have to know what is its magnitude. So therefore, what is this magnitude? This is where your other formulas come into play. So we're using this split on this other equation for magnitude of a cross product. And now this is just 1. This is just 1. But our tangent, unit tangent, is perpendicular to our unit normal vector. So therefore this one is also 1, because this angle is pi over 2. So now you have 1 times 1 times 1. Magnitude of the binormal vector is 1.
Awesome.
So if it's a really simple process, you just have to remember the relationship of everything and how it all ties together.
Okay.
But this equation here is going to be your key.
Okay. All right, and then I had one last question, and it was about the domain.
Okay.
So it was 14.1 on WebAssign, question 38.
Okay. Okay. So the equation was g of x, y, z is the natural log of 15 minus x squared minus y squared minus z squared. And you need to come up with the domain for it. So first thing you say is, oh, we have a natural log. So this whole thing has to be strictly greater than 0. because you cannot take the log of 0 or a negative. So now let's just add all of our variables to the other side. And right there's one of your options.
Okay.
And now if you were asked to graph this, it's a sphere with a radius of the square root of 15, but we are not going to include the skin of the sphere. It's going to be completely just the inside.
Okay. And the range would be,
Range would be negative infinity to positive infinity.
okay. So then for part A, where it says evaluate g of 3, -2, and 1, would that just be does not exist? Because that would equal ln of 0?
Let's see. Careful on that.
Or no, that would be, it'd be 0, because it'd be
It is
14.
just 0. Yes.
Yeah, it'd be 15 minus 14. Okay.
And actually, sorry, the range is going to be different. So we cannot go up to infinity. So we can get down to so your graph of a natural log looks like that.
Mm-hmm.
So we have a limit on how big our term inside the natural log can be. At the biggest, it's going to be 15. But it could go all the way down to 0 if we plug in the right numbers. So our range is only going to go up to
15.
not 15,
Oh,
but
ln of
natural
15.
log of 15. The biggest that your x would go then is out to 15 though. Or
Okay.
well, if you're looking at it in this way, they're quote unquote x. So your range is negative infinity up to natural log of 15.
Not included.
Not included.
Okay.
Correct.
Alrighty. And then my last question is, I didn't get through all of the WebAssign problems yesterday, so if I request an extension to work on them today for extra practice, how would that affect the points?
So it can only go up.
Okay.
So any question that you complete on the extension will, I'm not sure what the penalty is. I think it's in the syllabus. It's like a set.
It says
30% penalty?
30%. Yeah,
Okay,
it says 30%. I just didn't know how that would affect the grade that I already have on them.
Anything that you have completed, you get those points. Anything new you complete has the 30% penalty.
Okay.
So doing doing extension can only help your grade.
Okay. And how far back can I request extensions? All the way, or?
No, can only be within 24 hours of the due date.
Okay.
So anything that was due last night, you could still request your extension for.
Anything else I can't?
Correct.
Okay. Alrighty, that's all of my questions.
Very good. Wyatt, did you have anything else? And if you're talking, you're muted. Or Wyatt's just ignoring me. He took a nap.
You said it was 13 questions for this exam, right?
Correct.
Okay. Is it safe to assume that it covers at least one question per chapter?
I'm not sure if it's exactly one question per chapter, but it is a nice mix of a bunch of different things.
Okay.
There was no real focus that I thought on anything specific.
Alrighty.
All right, if you have nothing else, you are good to go. But I will say that the questions you asked today were good questions.
Okay, awesome. Thank you.
So it should definitely benefit you
To look over that.
today. Yeah, you won't necessarily get the exact question on the test, but there is definitely related stuff to that. And you won't have to do the whole thing of finding all the binormal or the normal, finding a whole unit tangent vector, normal vector, binormal vector, normal plane, oscillating plane. You won't have to find all of those, but the skills to do all of that will come in handy.
Alrighty. Awesome.
So very good. Good luck on everything today,
Thank you.
and we'll catch you later on.
All right. Take it easy.
Can you hang out for 1 second? I want to talk to you about something. I'm on the phone real quick. I'll be right
Okay.
back.